Alright, so we're going to make a start now. Okay, awesome. Welcome to CAD Software. Okay, this workshop comes in 3 parts total. Okay, the first part, what you guys are doing now, is going to be 2D sketching and laser cutting. Next week, you must come back and do the second one, otherwise you won't actually get your badge under UNSW Making. That includes 3D modeling and 3D printing, which Michael is doing right now in there. Okay, and then the third one is going to be advanced CAD. So in that one, we'll just be doing a few more techniques in CAD and trying to get some sophisticated models going. Hopefully by the end of these 3 workshops, you'll have a pretty good understanding of how, I guess, computer modeling works. Okay, we can hopefully build detailed models of whatever you want to make, or whatever you want to render and so on. And then from there, you should be better equipped to sort of design your own stuff. Okay. These stuff, obviously, a lot of you are probably here for Engine 1000 and DigFab induction, but realize that these kind of skills are actually quite useful outside of your coursework. Okay, these are quite useful if you want to make any cool project at all, and so we sort of urge you to do that. Okay, so this workshop's going to be quite quick. Okay, especially the sketching bit. We're going to actually go quite quickly through it. I'm going to do a pretty complex model, and it's going to need everyone's cooperation through this. Then we'll do a bit of the actual DigFab component, so a bit of 2D sketching, and we'll do a bit of DigFab, and then from there we'll go to jump to the laser cutter, and we'll sort of show you how to cut a piece out, okay? And then you can sort of, if you want to stick around and cut your own piece, I'll let you do that, okay? So hopefully you guys can sort of come out of this with some sort of thing. Cool. So, again, here's our schedule. As is, I'm not going to go over too much, but basically it's going to iterate between this week and next week, okay? So you must come to both if you want that induction, okay? Cool. So I'm sure a lot of you have heard about us before. We are Creates. We're a student-led society focused on driving what's called the maker movement, okay? So we focus on trying to, I guess, bring people, into this whole inviting culture of trying to build stuff. Because we think it's really cool, and there's this whole community, this whole movement, and we're trying to push it across UNSW. We just do our own projects, which you might have seen. So you might have seen UNSW's submissions for Vivid. We are actually the hosts for that team. So every year we send Vivid teams over. We also do what's called Droid Racing Challenge. We're doing a new one this year as well, which is basically cars drive by themselves. It's computer vision. So if you're interested in that, let me know. Cool. Before I make a formal start on terms of theory and sort of getting started on some of the more practical work, just 2 things. At the end of this workshop, there will be this iPad here, but there will also be the Google Link form, which I'll send at the very end. These will basically be your sign-in to this workshop. If you don't fill it in, you will not get inducted, and that's a warning, okay? I will check every one of you up here. So that's why I don't want you to do it just yet, is I need to check ZIDs and make sure that you're actually present, just because it is a formal induction process, okay? Does that sound good for everybody? Secondly, I have 2 ARC forms I'm now going to hand out. If you could, in your best interest, fill these out, pretty much because we get pizzas at the end of this, okay? So if you fill that in, we get some money and get some pizzas, okay? Sound cool? All right, so I'll sort of hand those out for 10. And you can figure it out on your own. Cool. So, computer-aided design, which is what we're really, for the most part doing in this workshop, is basically about trying to model we're just trying to create digital representations of models and objects that we like to use in real life. So you can pretty much design anything you want, and that's the whole point of CAD, is instead of previously, you might have thought of a bunch of engineers in a room making technical drawings, a bunch of sketches in some sort of workshop. Now we can just jump on our computers. We can sort of make a detailed model, sort of view it from different angles. We can sort of tweak and customize as we need. And computer-aided design is just one of those useful skills that every maker and every engineer kind of needs to sort of design whatever they wish. Okay, and this is actually quite useful because it extends beyond just designing it. We can sort of push that off to manufacturers. We can sort of make visual renders for reports, for example. So say for Engine 1000, if you have the upcoming report, your final one, you might make a render of your model, for example. And that will help you give marks, by the way. And it's kind of useful. We can also analyze these structures, so we can sort of test how strong each one is and how they respond to some sort of loading. Okay, so computer design is quite broad and useful. Whoops. The other thing that's important to note is what we're going to be working in Fusion. By the way, who has Fusion already and who doesn't? I'm assuming everyone has Fusion. Does anyone not have Fusion? Can you get Fusion in the next few minutes? Can you get Fusion, yeah? Okay. I'm going to get your help on it. Reinstall it. Yes, reinstall it if you get that issue, usually once you reflush it. So just uninstall and then reinstall it, and it should fix the issue, from my experience. Yeah, all right. Yes, you have an issue as well? Create an account if you haven't already, sign in if you have 0. Okay, so Fusion 360 uses what's called parametric modeling, okay? Parametric modeling is basically, in layman's terms, basically we can generate any sort of model using a series of numbers or variables called parameters, right? So you can imagine that if I created a box of size 50 by 40 by 30, instead of explicitly setting that size as those numbers, instead it allocates it to 3 different storage values called variables, so it might be T1, T2, and T3, okay? And we can change those parameters at any point in time, which allows our model to shift and change, okay? And we'll see this very soon when we do, when we actually do the sketches, is you'll see that you can actually change the size and shape of the model at any point in time using parameters because of parametric modeling, okay? So there's a difference between that and absolute modeling, but the main thing you need to know is it still results in this really high and accurate design that can be modeled, that can be tested quite easily, but at the same time it is really high. It basically allows you to shift the design at any point, and you can scale it and so on, and there's a whole different set of advantages. We don't need to go into the nitty-gritty of that, but that's what you need to know. Possibilities are quite limitless in terms of what you can do with CAD. We can prototype designs, as I said before. We can generate renders. In this case, what I did was I modeled my drone chassis. I used a software similar to Fusion called SolidWorks, which worked quite well. And so I modeled it in SolidWorks, and then I produced it in real life. So I used a laser cutter alongside hacksawing some tubes. And so with that sort of, I guess, the whole thing there, we can sort of send those jumps off of the laser cutter and make that entire chassis, okay? And this is all possible only because I have CAD, right? Making something like this without CAD is actually quite difficult in terms of mapping everything out in space, but also getting that sort of detailed shape going for the laser cutting, okay? So it's quite useful, and so it's important to know. What software we're going to be using, I don't have the link to the guide because I haven't written it, but I'm pretty sure most people here have Fusion, so I'm going into too much detail. It's a really easy to learn platform that we're going to use for CAD, okay? It's free for all UNSW students. You have some sort of license that you can obtain for students. It stores everything on the cloud, okay? So if you need to log in on another computer, you can wish to do so, but that's pretty much what you need to know about Fusion. It's quite easy to learn, and that's why we're teaching it here. Cool. That's pretty much it in terms of theory done. Now we're just sort of going to start to enter practical. I have a few slides in here. I'm not going to probably use them because they're really not necessary. I'm going to instead sort of just show it in demonstration. Okay, so we're going to do quite a few things. We're going to play around, and then there's going to be one sort of theory segment in the middle, and hopefully in the next 40 minutes we can sort of make and design something, okay? Yeah? Cool. So, I take my little sip here. What you need to do is obviously run Fusion 360, so I'll just check that I'm recording here. Awesome. Okay, so you want to run your Fusion 360 software. So, I ran mine. There we go, it's running there. And it likes to always not responding for a little bit, that's just because it's waiting to load. Okay, it's not actually crashing, it's just waiting to load. does take a while to load. It's running on based on the CPU, so based on how nice your laptop is, it will load at different speeds. But if everyone wants to sort of boot it up, okay, and anyone that isn't ready, please put your hand up, okay?
Yo, we're having a Fusion download issues. Sci-fi?
Yeah.
No, like,
One person. All right, does everyone have an open somewhat? Yes. All right, so cool. So let's get a move on because we got about 35 minutes to do this now. Okay. what you should do is you should have the workspace open. I'm going to quickly explore the overall space. Your thing might look a little bit different to mine, so I'm going to sort of correct it so that it looks exactly the same. Okay, that's what it should look like. A blank white canvas, some tools, and that's pretty much it, okay? So what I might just quickly show you is a few things, so let me just swing around a little bit, okay? So we have on the left-hand side here, so everyone can see my mouse up here. Everyone can see this is basically where all your projects are stored, okay? And I have a lot there, okay? Your store your projects are all cloud saved, okay? So just refer to that at any point. Then up here we have the sort of file menu, okay? So you can start new files from there, print, install, and save. When you work on your model, whenever you save, it's saved on the cloud. So don't worry too much about saving as a physical file. Then obviously preferences if you need it. Okay, now to the more important stuff. This is the toolbox, okay? So all the tools that you need are on this upper menu. Okay, all the tools that we're working with are sort of in the first three here, okay? And then the browser basically tells you any objects that you create. So we'll get onto that more when we do the third workshop. There's not too much in the first two. This is on the top right called the viewfinder. You can change your view at any point, right? So it's difficult to see, and I'll show you why in a moment. But pretty much the viewfinder allows you to switch what perspective you're looking at it from. Down here is what's called the timeline. Okay, I'm going to actually close this so that I don't interfere with them. Okay, so on the bottom we have what's called the timeline. The timeline is quite useful. It tracks a huge history of basically your entire model. Okay, so as you work on the model, you can actually animate that and animate your model coming to life, which is pretty cool. Next thing on the bottom here, and most importantly, the first thing is to select the layout grid and the view settings here. This will actually show you a plane. Some of you will already have it, some of you won't. So you can select layout grid of here, and you can sort of see where you're at in space. Okay, so that's a flat ground plane. Okay, and that's known as the top plane. And lastly, if you don't have a mouse, which obviously we recommend any sort of computer design, if you don't have a mouse, there are some camera settings which you can use here. So down here we have orbits. So orbit sort of lets you play and move your model around like this. Okay, and then the pan lets you sort of shift the camera in sort of like a translation. Okay, so we have these two types of camera tools, and you can also use the viewfinder on the top right, like I showed you before. Okay, either one works. Okay, don't have to use both. That's up to you. Okay, now we're gonna sort of get started. Is everyone ready to go? Yeah. All right. So what we're gonna do is we're gonna create a sketch here. So I'm gonna go to the top left, create a sketch, and basically what a sketch is a drawing on a flat plane. So you can imagine that I'm going to be, say, drawing a flat drawing here, but I can orientate this piece of paper on any direction, but no matter what, that drawing is always flat. That's the key thing you need to know about sketches, okay, is that drawings are always flat. Having said that, it's an essential sort of skill that you need to know before you can really do proper 3D modeling, because sketches form that fundamental basis in understanding how 3D processes consequently work. So it's actually quite important that you understand that. And so what I'll do is I'll just repeat that process for you in case you missed it. Is you go create sketch, and we can start a sketch on any of the planes. You can select any of them. I always draw on the top plane, but that's just preference. It doesn't actually matter, okay? One of the first things we're going to do is we're going to draw a line, right? Okay, so this is going to be very easy. In the top menu here, in the sketch menu, press sketch, press line. You'll notice there's an L indicated on the right-hand side. That just means that the shortcut key is L. So I can either click L or I can press the L button, and it will select the line tool. The way to use tools in Fusion is quite easy. Left-click your start point, left-click your end point. That's it, okay? What the line tool obviously does is then it allows you to actually chain several lines together. So you can left-click again, and you can sort of close your shape if you want, okay? And we can create some sort of quadrilateral there. Sorry, that's not quadrilateral. Anyway, we can form some sort of shape, okay, using these lines. And so the process is that for any tool that you see inside the sketch menu, it's quite easy. You press sketch, and then you select your tool, right? left click the start point, left click the end point, and then you can sort of tweak with the size later on, which I'll show you. Okay? But the main thing is, hopefully, what you should start doing now is let's start taking a look at a few of the other tools. Let's try and get a little bit more comfortable with all the other tools and how to operate them, and we'll sort of look at some of customized models and something more detailed, okay? Something more practical. So I'll just show you again, but instead for rectangle, I'm going to choose a 2-point rectangle here. I'll left click my start point, left click my end point, and that's it for a sketch. Okay, it's quite easy, shouldn't be too difficult, and it should be a breeze for everyone here. Okay, I'll do it again for, let's say, a circle. Okay, left click a start, left click an end. That's it. Okay. Does anyone have any questions about that process? It should be reasonably intuitive, which is why we choose Fusion. Yes? Or flats? No, it's because his viewfinder is yeah, and then I'll sketch. Great sketch. Yeah, and it's like a plane. Any plane, any plane. Yep. Yep, there you go. Okay, anyone else have any issues started using those tools around? Okay, is everyone following along fine? I'm not going too quick. Awesome. So, we've done some basic shapes, and yeah, that's all right. But let's start working with some of the more tweakish tools, okay? So feel free to explore these tools on your own. I'm not going to do that for you, okay? You can explore all these tools on the bottom, on the top. On the bottom, we have some extra tools, which I'm now going to show you, okay? There's the main free fillet, trim, extend, okay? Then there's offset, mirror, circle pattern, and rectangular pattern if you wish, okay? But what I'll quickly show is some of the tools here because they're actually very useful. Fillet creates a round around a corner, okay? It basically rounds out the corner and makes it not sharp. So if I select the fillet tool, which is here, and I select, say, a corner, it will automatically round that curve, and you can specify a size. So in my case, I'll put 75 mils, okay? And as well, I can also fillet by selecting 2 lines, like 1, 2, and it'll do the same thing, okay? So fillet on a corner intersecting 2 lines like so, okay? And all you need to do is press enter and it'll fillet it unless you want to specify the size, okay? Does everyone get that? Yeah? All right, the next tool we're going to use is going to be trim, okay? And what trim does is it basically cuts certain lines that are trapped between 2 others. It's quite complicated until I show you an example, which I'm going to do now. Let's take a look. And sorry, I forgot to explain the camera. If you have a mouse, this is where it's advantageous, okay? You can use the middle click to pan to sort of orbits. And you can press shift and press the middle click to zoom. And you can use control and middle click to pan, okay? It's only applicable if you have a mouse. If not, use the tools underneath, okay? The camera tools or the viewfinder. Okay, but if you do have a mouse, that's where it comes in handy. This makes it very convenient to shift the cameras around. So if you don't, click the top button here. Yes, William?
Well, actually, they can. If they have touchscreen, they can use the
yeah, touchscreen works as well, but still pen and all that I think is a bit hard. Okay, does everyone get that? Okay, so what I said was before was we're going to use the trim tool. Okay, so it's learned about the letter T. So if you want to select that now, you can. And what the trim tool does is it basically cuts any line between 2 intersection points. So say, for example, I'm going to zoom in here. I've just made a bunch of drawing shapes, and I want to make it one huge blob, okay? For no apparent reason, I just like a huge blob, right? So what we're going to do is we're going to trim all the lines in the middle, right? And the way we're going to do that is all you need to do with the trim tool is sort of raise your mouse over some section that you want to trim, and cut it, okay? So say, for example, this section, this line here, it's segmented between this line in the middle and at the bottom, and I can trim that using the trim tool. So all I need to do is select that. Alternatively, and a little bit more risky, and I don't recommend it, is you can left click and drag along different lines, like so. But ultimately, all you need to do is trim some lines out, okay? Like this one here, I don't need that excess around the corner, so I can just trim that. And you can sort of go around trimming as much as you need, okay? And there we go. Suddenly you have some amorphous block, okay? And the trim tool is useful for that. As well, just as useful, is the extend tool. What the extend tool does is it extends any line in a straight path until it hits something, okay? And so it's quite useful for creating new lines and making it nice and straight, okay? Where it might, you might sort of need a line. So for example, if I wanted to extend this line here, I can extend it out like so, right? And this line, say for example, I can extend it out like so. Okay? The reason why it's segmenting like that is because we previously trimmed those lines and now it's just trying to recover those lines with the glitch. But usually all you need to do is extend that out like so, and you'll get your lines back. Okay, so we can do that. Does anyone have any questions about those three tools? There are a few other tools that I would like to show you, okay? But instead of just going through and trying to make an example, what we're going to do instead is we're going to try and model something a lot more complex, okay? Before I can do that, I need to plug in a little bit more theory, okay, on how parametric modeling is actually really great, but also really annoying. And after I show you, give you a quick talk about that, then we'll start working on an example, okay? Everyone cool with that? Awesome. So I'll just quickly bounce back to my slides here. Right. Okay, so I've already shown you all of that. Right. Definitions and constraints is this huge issue with parametric modeling. And it's actually quite important you get this right, because parametric modeling relies on this, right, to generate all your models accurately, okay? So if you're using what we use, what's called absolute modeling, okay, what you can end up getting is basically your model can't change shape, and so can't actually generate a new shape out of that, which can be problematic. And so when we try to use parametric modeling, in order to have that high precision, we need to make sure that we actually specify every single parameter that it needs, right? Because that's how parametric modeling works. In order to do that, there are two things we can use, right? The first one is the dimension tool, and I'm about to demonstrate this when we get to it. But the dimension tool basically allows you to specify the size of any rectangle. So what you'll notice is when you were drawing those shapes out before, you were sort of drawing them without any sort of size, and they're going to 0.001 millimeters, right? When we use the dimension tool, you can first draw your shape, then dimension it to size. So and I'll show you this in a little bit, but dimensioning is actually quite important for making sure everything is the right size that you exactly want. Otherwise, the software will assume their own dimension, and that might not be exactly what you want, right? But when you specified it, it will lock into its actual size, and it will make sure that that dimension gets satisfied, okay? On top of that, not only does it need the dimensions, it needs to know its position, okay? What we always defer is inside Fusion, you'll notice there's this little sort of circle icon with a black and white section, okay? This is sort of what's called the origin, or the intersection between sort of like the X, Y, Z axis, okay? The origin is a useful reference point from which we can model everything out. And so what you should always do is make sure that your model is in some way attached to the reference, the origin, or have some sort of distance reference to that. So I'll show you an example of this pretty much very soon. But the last thing I want to talk about before we do that is constraints. Constraints is another way to sort of restrict and apply rules between certain shapes. And it's very useful to sort of make sure that your model doesn't use too much maths, okay? Because I'm sure a lot of you probably aren't a fan of maths, and we can use constraints to help us avoid certain steps in our models, because it has certain rules that are actually very useful, and we'll be using one of them very soon, okay? So, having said that, let's quickly just do a quick brief on dimensions and constraints, because it's quite useful. So, what I'm going to do is I'm going to delete my original sketch here. So if you have a tool open, just press the escape button, clear that out, okay? And then from there, hello guys, just watching from the file. And so what we're going to do is I'm going to draw a rectangle, right? A very simple one, okay? What we're going to do is we're going to make sure that the rectangle is exactly 70 millimeters wide and 10 millimeters tall. Okay? And so what you'll notice is the rectangle is originally blue, which means it's not actually defined, okay? Which means the computer doesn't actually know the full size of our rectangle here. So I'm going to use the dimension tool. Sketch, dimension. Conveniently, it's also denoted by the letter D. Hence, you can press the letter D at any point and you'll activate the tool. You'll select the tool, we'll select an edge, and it would withdraw a sort of dimension line out, as you can see here. Okay? So you click that dimension, and now it will let you input a size. Okay? So, say for example, I want, as I said before, 17 millimeters wide. There we go. Okay? And now I can zoom in here, I can extrude that out, and I can make that 10 millimeters high. Suddenly a very small rectangle. Okay? Awesome. Cool. But you'll notice it's still blue, right? And that's because this rectangle doesn't have a position that's defined with respect to our origin. At this point, the computer can actually put my rectangle anywhere on the screen. And you can kind of see this if I left click and drag my model around, it's letting me do that because it doesn't actually know where to put it, right? This is a problem in parametric modeling where it kind of needs to know exactly every nitpick detail. It seems complicated at first and it seems annoying, but once you do practice, you realize why it's very important to us. Okay? So in this case, it's important that we have a rectangle sort of with reference to the origin. One way of doing that is using constraints, and I'm going to demonstrate that right now. What we're going to do is I'm going to take the bottom left corner and I'm going to apply a constraint that forces it to connect to the origin, such that the bottom left corner is always in conjunction with that origin. Okay? That way, its position is fixed and its size is fixed, which will make it defined. Does that make sense, everybody? Yeah? You can drag it, but I'm going to show you the more formal way. Yes. Okay? So, what we're going to do is I'm going to left click that corner, because that's the corner I want to constrain. You can click any other corner as well. Okay? Then I'm going to control click the origin. Okay? And you'll notice that now we have 2 points clicked here, and they're both highlighted in blue. Okay? That's what's important here. So I've selected the 2 points, and now I'm going to apply what's called the coincident constraint. Okay? And that basically tells us, put them together. Okay? Make them touch. Okay? So here I'm going to apply the coincident constraint, which is on the right-hand menu here. So a bunch of constraints here, and in this case, coincident. So I hit coincident. And you'll see that the rectangle suddenly flicks onto the origin. And now, if I attempt to move my rectangle, it's not going to let me, because it's fixed in position defined by that constraint and defined by the dimensions that we set it. There's no way now, and you'll notice that also, if I zoom in here we go, you'll notice that my rectangle is black in outline, which means that it's fully defined. Okay? That means the computer knows exactly what I'm asking for. Okay? That's quite important. Any questions about that? Where do you get the sketch palette? It should be in views. It should be one of these kind of menus here on the bottom. Okay. Cool. Did everyone get that? Awesome. So, now we're actually going to do a more interesting exercise, and I want everyone to follow along. Okay? It's not easy. And trust me, there's one step that sort of kills everyone, okay? So I want everyone to focus, okay? We're going to go through this. By showing you this process, it should give you a basic understanding of some of the tools, okay? And then I might give you some practice exercises to do on your own, okay? I might give you some. Right. So, let's delete that sketch again, okay? And we're going to generate our own sketch, okay? What I'm going to do is the very first step, I'm going to draw a circle of size 75 millimeters. That's all I'm going to do. Circle of size 75 millimeters. On the origin, so that it's defined, right? Does everyone get that? Does anyone not get it? Well, anyone else? 75 millimeters. Yeah? In diameter. Yes. Its position is defined on the side. Okay? Cool. Alright, so now that we've done our circle there, okay, what I'm going to do next is I'm going to draw a line that goes straight up. Actually, no. Yeah, we'll do it straight up. Okay? And I'm going to make it at a distance of, let's put it at 125 millimeters. Okay? Like so. 125 millimeters vertical line above. Okay? You'll notice that when you align the line on the vertical axis, it sort of locks in there, and what ends up happening is this sort of shape comes out. This is known, this thing here is actually known as a constraint that aligns it in the vertical axis. Okay? So that symbol there tells you that it's actually constrained to be always vertical. Okay? And that's because when we drew it, we aligned it to the vertical green axis. Okay? That's why that's there. Yes? Sorry? Yes, you can. You can always left click the constraint and delete it. But you'll notice that the line is blue because it doesn't know the angle of the line. It's no longer restricted because it's blue, right? Because it's no longer defined to be exactly this angle, right? Whereas if I had the vertical definition, it means that that line must be vertical and must have a length of 100. Yes, because you drew it from the origin, in my case. Your line should be black. Your line should be black. Yeah? Black means defined, which is a good thing. Okay? What we're going to do next is I'm going to draw another circle. Quite simple. I'm going to draw another circle here, and I'm going to make it at the top of that line at a size of 50 millimeters. The size of 50 millimeters. Yeah? Okay? Shouldn't be too difficult up until this point, right? The next thing we're going to do is I'm actually going to convert this line here into what's called a construction line. Because what I'm trying to make here is this interesting sort of arm shape, okay? It sort of goes in top and it sort of tangents into a larger shape. And you'll notice that that middle line chops between my two circles. That's kind of not desirable, okay? Instead of trimming that line, which would remove 125 mil spacing, what I'm going to do instead is convert it to what's called a construction line. Okay, and a construction line basically models it as non-physical geometry. So you'll notice that every black line that we see here sort of maps like an edge, okay, and an edge on which a physical edge for any sort of shape, okay. If I use a construction line, it means that it's no longer an edge and it's sort of a representative line, right, which is dotted. And you'll see this as I show you right now. So what I'm going to do here is I'm going to left click my line here, and I'm going to hit construction here. Okay, there we go. So we have a construction line, and you'll notice it's dotted. What this means is that when I say, for example, cut my model out, it will not cut this line out because it's not physical geometry. It's just there to help us build further geometry on top of it. Does that make sense? That's why it's called a construction line. Okay, that's how construction works. Okay. What we're going to do next is we're going to build a slot in the middle. Okay, a nice rectangular slot. And the way we're going to do that is actually quite simple. In the sketch tool, we're going to use the convenient slot tool. Center to center. And what I'm going to do is I'm going to click the center of the two circles. And I'm going to pull out a nice interesting slot here. Okay. And then I'm going to make the width of that slot equal to 30 millimeters. Okay. So I'm going to use the dimension tool here. Here's what you guys need to sort of watch. Here's a new feature of the dimension tool which you might not know, which is if I left click one object and I left click a second object, it doesn't give me the length of each one, but it gives me the distance between the two. This is actually quite a necessary feature, of course. Just like indicating lines, we can use clicking on multiple objects as a tool to help us define things like the distance between two objects, or the angle between two objects. Okay, that's actually quite useful to have. So in this case, I'm going to make that 30 millimeters wide as a slot. Does everyone get that? Whatever you're doing, you tell me. Yes, question up. Yes, center to center slot, and you select the center of both circles. Yeah, and pull out. Click. Yeah, click. Click. And then now specify the dimension. Okay, so you can always draw your shape first, then dimension it afterwards. Yeah. Yes. Anyone else having issues? Does everyone else have this? Yep.
How do you select it so you can get the 2 buttons?
So dimension, use the dimension tool. Click the first line there, click the second line. Oh, you've already done this. Yeah, click the first line. Yeah, and then just click it anywhere and you place the dimension and then you can swipe. Okay? Anyone else having issues? Okay, cool. The next part is very difficult. Well, at least when I used to run this workshop, this was the hardest step, okay? So hopefully everyone can follow along. What I'm going to do now is you can see that our shape is starting to form. And what I'm going to draw is a line that is tangent between the two circles, okay? If you try to math this out, good luck, okay? Because mathing it out is kind of complex because we want it to be tangent on both sides. And you could spend billions of years trying to math that out on paper, or we can use what's called the tangent constraint down in our constraints menu. Okay? The tangent constraint is kind of useful. You see it on your screens. Okay? The tangent tool is quite useful because it can automatically figure out the exact tangential point and stick your line or other object to that surface. Okay? So what I'm going to do is I'm going to draw a line. I'm going to make it tangent to both circles. Okay? So let's make a beginning. Let's make a start. So I'm going to select the line tool here. And then I'm going to draw my line out, not touching the circle. I can make it touch the circle. I can make it sort of leave out. So in my case, I might actually just leave it out. And I'll draw it roughly to the shape of what I expect. Right? I expect the line to sort of tangent in there. I'm just going to draw it arbitrarily far out. I'm not going to make it stick yet. Okay? Now that I've drawn the line, I can now make it tangent, and I can use constraints to put that line in place. Okay? So what I'm going to do here is I'm going to left-click the line here, and I'm going to apply the constraint with some other geometry. In this case, we're going to do it to one of the two circles. So what I'll do is I press Control-click, and you'll notice that now I've highlighted two objects, okay, the circle and the line, and I'm going to make sure that both of those objects are tangent to each other at all times, okay? And this means that we're going to hit the tangent constraint here, and you'll see that it suddenly will snap onto it, okay? And you notice that it is indeed tangent to the circle there. Does everyone have that? Okay? What we can do now is we can apply the same constraint, but now not just on the first circle, but on the second circle, okay? So, I'll left-click the line there, I'll control-click the second circle there, okay? And again, I'm going to apply the tangent constraint there. You'll notice that my line now turns black, because it's defined. Yes?
So when you say tangent constraint,
that constrains the direction of the line and the surface of the circle to always be tangential to each other. That's what I mean. So let me show you what I mean by that. It might be a bit confusing. It's say that I only had the tangent constraint to the first line, the first circle and the first line, right? This line is free to move anywhere along my geometry, but it must always be tangent to the circle, no matter what. The line must always extend on the tangential axis. Yeah? Does that make sense? Cool. So again, we're going to apply the tangential constraint to the second circle, and that fixes it in place. And you might ask, why don't I just click all three objects and apply the tangent constraint? Well, clearly, these two circles in no possible geometry, unless I shrunk that length there, can ever be tangent to each other. So if I tried to apply a tangent constraint for all three together, it would not work. the computer would go, this is not physically possible. And in fact, it won't let you press that constraint, right? But you can always apply it for 2 and then 2. What you'll notice here is obviously my line is not really on the shape, right? I know it's tangent to both circles in direction, right? But its length is still sort of weird, right? It's still awkward. Our shape is not really complete. What we can do is 2 things. You can use trim and extend to extend or trim your line to touch those circles, which is one way, or you can use constraints. So I'm going to show you both methods right now. So the first one I'm going to use is trim and extend. So up here, I'll press extend, and I can left click that line there, and you'll notice that it will extend to the next possible intersection, which is the tangent point for the top circle there. Okay, so I'll left click that, and suddenly it would extend to that tip there. Okay, and the next one we can use is trim, so I can use the shortcut key T. Okay, and now you'll notice that down here, I'll zoom out a little bit, we have a little extrusion. Okay, and I can left click that and remove that extra segment there. Okay, so you can use the trim and extend tools to achieve that if you so wish. Play around with it. Alternatively, you can always do constraints as well, right? Because what we need to get it to constrain correctly is that the endpoints of the lines are always touching the circles, right? Because they're already going to have contact points at the tangents anyway. If I apply constraints such that the endpoints of the circles touch the circle, means that it's going to be exactly tangential, right? So I'll left click the point here, I'll control click my circle, I'll hit the coincident button, and then I'll repeat that for the other one. And you'll suddenly notice that its length adjusts such that it's perfectly tangential on that left-hand side. Does everyone get that? Does anyone not get that wrong? One? And out of the wood, it's quite this is like, you notice that it's sort of like, this is not my edge. So that's what's important when I say keep everything fine, make sure every single step. Anyone else having issues? Really? No one else having issues? That's really good. Awesome. So, what we can now do is you can repeat that process on the right-hand side, and you're probably going to go, oh, I don't want to repeat all the steps, right? What we can also do is what's called the mirror tool, which is going to be the last thing we're going to learn today in 2D sketches. Okay, and what we're going to do is we're going to reflect this line, because it has an axis of symmetry in the middle, we can reflect that line from the left side over to the right hand side, okay, using the mirror tool, okay, and I'll just show you how to do that. In the sketch menu, you can hit mirror here, okay, and then from mirror, you can left click the line there, and then select the mirror line, and select the middle line there, okay? And that will reflect it onto the right-hand side. If I press OK, you can sort of select that, and it will mirror it onto the other side. Note that you can mirror more than one object as well. You don't just have to do that one line. You can, if you had other lines you wanted to copy over, you can do so with the mirror tool. That's the whole point, right? You're just mirroring it and flipping it on a central axis. The very last thing, yes, did you need help? Yes, I'll repeat that for you. So let's just undo our progress there. Okay, so you're going to select the mirror tool up in the sketch menu here. The mirror tool. You'll select the object that you wish to use, which is going to be, in this case, this object is the one we're going to mirror, that line. Then you'll select the mirror line, or the axis of symmetry in this case, which is going to be in the middle. And you see a preview of your line here, and you press OK. and your line will mirror automatically. Okay, and it replicates that geometry. And it also mirrors constraints. That's the whole point, right? It mirrors that line which holds constraints originally. So that's what magic is about. Okay. The last thing, obviously, now is an exercise for you guys, which is we're going to trim our model to make it nice and neat. So hopefully now you have some sort of knowledge of how to use the trim tool. Let's pull that out with the letter T. Okay, and we'll sort of zoom in, and I don't want this line. I don't want this arc going through the middle, so let's remove those lines there. Okay, and then go the same on the bottom side, so trim those off as we go along. You'll notice that there's an error message on the bottom right, okay? This error message is basically saying that when you trim some sort of geometry, it needs to modify any constraints or dimensions that may have been affected on that line. If you get that message, it's totally fine, but what you do need to do is zoom out and check if your model has any blue lines or blue geometry, because that means that you may have impacted the definitions of the rest of your model, okay? It's important that you check that, and it's important that you try and correct that because before it becomes a nightmare, okay? Does everyone get that? What you should ultimately get, I'll get to you in a moment, is some sort of shape that looks like this, and if you left click that shape and that shape, they're two independent shapes, and that's what you should ultimately get. You'll notice that the construction line we had at the very beginning doesn't actually make any difference to the geometry. It doesn't actually recognize it in physical domains. Okay? Does everyone get that? Does anyone any questions before I get to you? Just sort of give you a hand. Yeah? Cool. I'll get to around I'll get to you in a moment. Yes. Yeah. It's usually because it's not actually touching. You need to use either an extend or grip to drag the line onto the touching. You're about to do that? Yeah. So zoom in. It's very, 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 very close to that touch. Check the other one. Check the other one. Yeah, see? Yeah. So just extend it or make it towards the highlight over it. See, it's a dimension line. It's purely dimension. So you don't need to worry. You can always delete it. You go straight to draw. Yeah. So yeah, if you delete it, you delete the definition, right? But then you can dimension the outer circle here. Dimension the outer circle here. Yeah, it's a dimension line. Yes, a little bit misleading. Drag it out. Drag it way out. Drag it way out. Yeah, there we go. Good. Now tuck it in. Press enter. So remember this application. Okay. Now. No. That's good. You won't be doing that looks at dimension. Escape. Don't worry about this. Yeah, anyone else have any problems? Cool. All right. So, if everyone has that, what we might do is, I want you to start thinking of something you want to laser, some sort of design. okay? Hopefully what can happen is that by the third workshop, we can sort of, because you guys will be inducted, means that we can actually cut something out for everyone, okay? So if you want to cut something out, I have a bunch of 3mm plywood, and if you want to cut something small, maybe let's keep it to 50 by 50 millimeters, nice and small, okay? So I have to go to Bunnings and buy that material and sort of walk my way back. It's quite hard, okay? We'll try and keep it material nice and small, okay? But if everyone wants to come up with some sort of design over the next 2 weeks, 50 by 50 millimeters, and you can laser cut it on some 3mm plywood. How does that sound?
Oh, yes. Sounds okay.
Yes.
When creating one of these documents, do you often like limited dimensions or is it just like typical?
Generally, I like to draw a construction rectangle. So rectangle out of construction lines, and then draw my stuff on top of that. Okay? If you don't like doing it that way, you can always scale it with the sketch tool. Okay? Yes?
Do we have to bring our own materials?
No, I'm for this little cut, I'm bringing the wood for you, but if you're using it yourself, yes. So I'll get into that induction process now. Okay? Is everyone clear with that? This next bit, you don't need your laptops, okay? This is all actually done on the computer inside the makerspace. However, for obvious reasons of not shoving 40 people, maybe 30 people around the basement and a computer, tiny computer, I'm going to demonstrate 50% of the process here, and then we will move to the makerspace and I'll show you the actual physical laser cutter and we'll work with that, okay? Sound good? So, if everyone wants to stick out here, but I recommend taking notes in some way, okay? Even though you might don't have a model, I recommend taking notes because there's a lot of steps and a lot of things you can think about when you're doing the laser cut, okay? And I want to make it clear exactly what, all the different things that I have a bunch of slides for, okay? Is everyone cool with that? So everyone still stay here, obviously, but I'm going to run through a whole bunch of different stuff, okay? And is everyone satisfied with that 2D CAD? Yeah? Okay? We have 50 minutes. Let's make this work. Please, everyone stay here, take notes. If you don't stay for this bit, I will not induct you. I will warn you now. If you don't stay for this bit, I will not induct you for the space. Okay? You will need this to do your DigFab. Okay? So, the very first thing is we're going to export our model into what's called a DXF file. Okay? So from Fusion, if I stop my sketch here, okay, I can go into sketches. Guys up the back, can I get your attention? Yeah? Okay? What you need to do is you need to right-click your sketch, okay? So just generated that sketch, and you can save as DXF, okay? DXF is the file that we actually need you to put on your USB, okay, to put on the laser cutting computer. That's just something you need to do, okay? So you need to do that on your own accord. In my case, I can save as DXF. I'm not actually going to do this one as a laser cut. I'm actually going to model my own real quick later on. But what you can do is you can press save as DXF and then save your file with a name, chuck it on a USB, import it into the computer, okay? And I'm going to show you that process now. So what was that? This one? Oh, okay. Cool. So now that we've hopefully saved as some sort of DXF, so what I might do is chuck it on the desktop here. Hi there. Okay. I saved my file as a DXF, and now on a USB, you're going to chuck this file on the laser cutting computer. Okay, and I'll show you that computer in a little bit. But pretty much, you'll run a software called Rhino. Okay. Usually on the computer, that's already pre-opened. If it's not, I have it on my laptop, so I'll just run it off mine. But pretty much, you'll have what's called a laser cutting template. Now, mine is actually incorrect, I think. So I will change those layers as we go along and explain all the concepts, which is why you need notes. Okay. But pretty much what you do is you import the model into Rhino. We modify the Rhino to program exactly what sort of cut we want to execute. And then from there, we can actually print that to the laser cutter. Okay. So I have a couple of slides for that. Here we go. So, laser cutting is basically using a high-powered laser to cut 2D geometry, in summary, okay? And it's very cool. Everyone likes to pull their phones out and record videos of it, but it's overall just this really high-precision tool that we can use in the makerspaces, and they can move in 2 axes of movement, okay? So it's not 3D. Usually, the motion of any laser cutting and any 3D printer as well is defined by what's called G-code, which is basically saying at 1 second, move to this point here, at the second move to this point here, the third second move to this point here. Okay? So that's how G-code works. It's just a series of steps and timestamps. Okay? Don't need to worry too much about that. In our makerspaces, we have quite a few. Generally, our whole lineup is defined by Trotec Speedies, okay, which is just some industrial grade laser cutter, okay? They're available here at MCIC, up at Williston X in the James and Kirby makerspace, down at Square House, down at Tyree. So there are a bunch of different units. The smallest size that we have, which is the 300, available here in MCIC, has a maximum size of 740 by 410 films, okay? Which is really big, and honestly, most of you guys won't reach that size, but just something good to know is the size you can cut up to, okay? When you have completed this course in DigFab, you'll be able to access those cutters there. So there's a bunch there, you don't need to worry about that. Just know there are a bunch in each space. The software you'll be using is Rhino, which I was showing you before, which we'll get to in a moment. You'll need to, I won't get you to actually install it for this workshop because it's too much of a nightmare to deal with. So instead, I'm just going to demonstrate, yes. Sorry? Windows, Rhino has a Mac evaluation as well. I believe so. Rhino has a Mac version. But regardless, you can always run it on the MCIC computer. Every laser cutter has an associated computer. You can always plug it into there, okay? So you don't have to. Before I can actually continue with the induction process, there is one thing I have to sort of show you, okay? Which is going to be, if you search up UNSW Making, okay, and some of you may already have this, you'll need to jump on the UNSW Making website, okay, which is just here. You'll need to log in, okay? I'm already logged in on the top right there, okay? If you aren't logged in yet, please do that. Sometime between now and sort of when you want to actually get the induction badge, and then you need to jump into badges, badge training or badges, and you'll go find, in this case, digital fabrication, okay? And you'll complete the online learning modules for this badge, which are already have them here, so I can't really show you. But pretty much on this page, so that's UNSW Making, badges, digital fabrication, you'll find this online resources, okay? You will need to complete the safety documentation and watch the videos. You don't need to do the training in person because that's here, right now, okay? And I will make sure you get checked off for that, okay? Make sure you do that before you actually get your badge, okay? Because otherwise you will not get it and will get flagged, okay? So, having said that, we can now sort of make a move on. Okay, so, as I said before, does anyone have any questions, by the way, about that? Before I move on?
Watching the videos?
Yes, it is. Watching the videos and doing the SWP, I think there is one for it, is there?
Yeah, I think this is...
There's a safety work procedure, safe work procedure. Please read that and declare it as read, okay? Cool. So, as I said before, and in any CAD software, we can export the model as a DXF or DWG, okay? And we're going to import that into Rhino, okay? Importing into Rhino is quite easy. So, let's jump straight to Rhino. So imagine now, you're walking up to the laser cutting computer, you have Rhino open, possibly on some sort of template, okay? And you'll get this, okay? And so what you would do is, the very first thing you're going to do is obviously plug in your USB with your DXF file inside. Then what I'm going to do is I'm going to type imports, and you'll bring in your model. In this case, let's just go with, I'm going to go with Rib7 here. Okay, it will open up this window. Don't worry about that, just press enter. And there we go, okay? Very tiny model, all right? In my case, why it's tiny is because of the scaling is wrong. So what I'm going to do is I'm going to re-import it. And I'm going to check, because I did this in SolidWorks, right? I'm going to check the model here, okay? Fusion 360 works in millimeters, but other software based on the template that you work with and based on the settings might work with meters. Okay? In my case, I actually work with meters. So what I'm going to do is I'm actually going to select meters here, and that should fix my scaling issue nice and big. Okay? That's all you needed to know is that when you're importing, sometimes you get scaling issues. That's just because the model units might be incorrect, so that's the setting for that. Okay? Once you have your model implemented here, we can now sort of start to clean our model out. So you can highlight certain shapes. So in my case, because I imported straight from SolidWorks, leaves this sort of drawing template that's really helpful. Okay? I'm actually going to delete everything on that. So I'm going to press delete. We don't need these lines here. We can delete all of these lines here. Easy. Okay? What I'm left with is an interesting curve shape, and this is actually an aerofoil. Okay? So, what I'm going to do now is now that we have our shape, there are a few things we need to do. A few things. The very first thing is I'm going to do what's called make 2D. Okay? So I'm going to highlight my shape. I'm going to type make 2D in the command bar. You can type this straight from the command bar. There's not like Fusion where you have to select tool. Just type make 2D. You press enter, and suddenly you'll notice it creates a copy. A copy above our original one. What you want to do is actually keep this copy and delete the original one. Okay? What this does is it actually flattens the model. Okay? So sometimes when you import a DXF, it might glitch out and it might not be exactly flat. What Make 2D does is ensure that it's fully flat on the surface. Okay? And this ensures that laser cutting actually works wonderfully. Okay? Once you've done that, this next process tends to be pretty interesting. But what you need to do now is we need to specify what kind of cuts we can achieve in laser cutting. So, back to my slides here. There are 3 different types of cuts that we can do in laser cutting. Okay? One is called a full cut, which is what you probably know. One is called scoring, and one is called engraving. Okay? I don't have images for these yet, but I'll try and get them in the slides tonight. But the main difference between these 3, a full cut cuts through the whole material. Okay? So when you want to cut an interesting shape and you want to actually detach it from your source material, you'll use a full cut. And so usually you might say cut the outside shape to actually remove your object using a full cut. Okay? Scoring basically does the same thing as a cut, but half or less power. Okay? And all it does is it leaves a very fine line that doesn't cut through the whole material, and it makes it really nice, sharp sort of vector image, if you so wish. And it makes it sort of used for aesthetics, and it can be used to sort of weaken the material at certain points. So say you have, which is very common, a piece of paper, and you have a sort of dotted line across a certain section. You can then, if you cut that line with a score, fold that line out because it's weakened, right? So that's what the score is used for, okay? You'll see a lot of purposes for it, but scoring is a very light cut and generally used for aesthetics. Engraving burns a large surface of the material, generally speaking, images, okay? So when we engrave, we tend to engrave pictures or diagrams or names, stuff like that. And I'll show you a few examples when we do a bit of laser cutting, okay? And I'm hoping that by the end of this, you know, maybe I might hand out some stuff. But we'll engrave a few things, and engraving basically does an image, okay? Instead of a thin line, instead it can do a full area if you so wish, okay? Engraving's quite useful. Yes? Yes. Generally, when you're trying to make wood bend, generally that is actually a full cut. And there is a specific technique which I'll speak with you personally about it because it's quite messy and have a script for it. So I'll show you that at the end. Okay? But when we're dealing with these different techniques, you can use any of these cuts. And I'm going to show you how to program each of these inside your model. Okay? What we need to do is we need to actually allocate cuts to our job. Now, these colors here, please don't copy them down. It's actually all wrong. Recently, what actually happened was a hidden ninja came into the NCIC and ruined all the settings. So now all the colors are different. Okay? I'm not sure who that ninja is, okay? But all our colors are now different, and I'm going to tell you the actual colors that we need. But having said that, we won't worry about that yet. First, we'll just worry about the fact that when you're doing these different sort of cuts, you'll need specific colors for those, and I'll tell you those colors as we go along. Okay? Some material considerations to think in mind before we actually get a start. Please be considerate about what you use, okay? I'm not sure what size of acrylic, I think it's up to 12 mil as well. But pretty much the main thing is, and a lot of you work with plywood, please only use internal plywood, okay? Don't use anything that has exterior grade or marine plywood or something like that, because what actually ends up happening is it releases a bunch of toxic gases when it burns, and then people die, okay? So generally speaking, avoid using exterior plywood. When necessary, you can use internal plywood, and I have some in my locker which I'll pull out, okay? You can also cut several plastics, acrylic being the main one, or polycarbonate. You can have clear and colored variants, translucents, if you so wish. You can also cut paper and cardboard, and the last thing, you can actually cut leather as well. So in the MCIC, we actually do a lot of leather work, and we actually highly precisely cut leather out to make certain items. Okay, so you can use that as well. If you aren't sure, yes.
With all these different materials, does the cutting process
Yes, in a little bit, a tiny bit. With certain materials, yes. So for example, leather, you need to make sure it's flattened and stretched out a little bit. With paper, you can't actually cut it. So there's certain positions of materials, but in terms of the settings, they're roughly the same. So it's about tweaking those numbers around and stuff like that. But other than that, it's more like positioning more than anything. Okay, and we'll get to see that a little bit. Okay? Any questions about that? Okay? If you're not sure of a material, please ask first. Okay? Always check with us first. So there's always a member of staff in the makerspaces. Check with a member of staff first, then cut. Okay? Images, I'll get to in a moment, but pretty much we can always engrave images. And your model's ready cut. No, it's not. I'm going to show you now. Okay, so let's say, for example, I want to cut this interesting shape out, and you should have imported this straight from Rhino. Okay, imported it straight from Fusion, sorry. So say I had a circle inside as well, okay, and this is my shape that I wanted to cut out. Okay, what I would do is I would first identify what line is being cut where. Okay, so actually I'm going to make it a little bit more interesting. Real quick, if you don't mind, I'm going to make this actually very interesting to showcase. Hi there, and we'll make that here. There we go. Okay, so we have some interesting shapes, and I want to cut out some, I want to score some on that shape. Okay, but I want to do it in a specific order, right? The text, hi there, I'm going to actually score, okay? And scoring is done on cyan lines. Okay, that's something you want to write down, is done on cyan lines. And the way to change that is in the template, there are a whole bunch of colors as you can see. Okay, my labels for each color is wrong. Don't follow it. Don't follow it. Okay, but we can change those settings by changing the colors. And what you'll note is that in the template, there is a light and dark score. Okay, corresponding to light blue and dark blue. Okay, so this traditional blue here corresponds to a dark score or heavy score, and the light blue corresponds to a light score. In this case, we're going to actually use the light score. What you would do is you'll right-click the layer, and you change object layer, like so. And you'll suddenly notice that the shape turns cyan. Okay, that means it's semi-light score. The next thing we're going to do is do internal and external cuts. Okay, if I cut the outside shape first, what would then happen is the material might separate from the rest of the sheet of wood, and then now cutting the circle is actually going to be pretty hard to get accurate because it's sort of already detached from that piece of wood if it wasn't flat. Okay, so generally speaking, we always choose to cut the smaller internal cuts first, then cut the external cuts. Always the process. Internal cuts, I think, are denoted by magenta. Sorry, red. Red. I think it's red. Again, the color change knocked me off. But change, again, in the same way, right-click, change object layer, and you'll notice that that circle in which I want to cut first is now red. Can everyone see that? Yeah? After that, Now I'm going to do the aerofoil on the outside, okay, which I'm going to do as an external cut, which is magenta, okay. So what I'll do is I'll select my lines, I'll right-click my site magenta layer, and I'll change it there. And what do you notice? Oh no, when I imported my model, my lines are not actually magenta, even though I changed the layer. If I select this layer, you'll notice that it is in the magenta layer, but it's not showing as magenta. Okay? This is a very common issue, and that's why I'm trying to address it now, is if you do encounter this on the laser cutting computer, here's how you fix it. You jump to properties, and you see the display color here. You change that to by layer, and you change print color to by layer. And that changes it so that the color is based on the original layer, which is magenta. And then if I say deselect, you'll notice that now my lines are magenta. Does that make sense, everybody? Yeah? This is actually quite important because a lot of people come in and we sort of panic because we're not actually sure. That's the actual fix for it, okay? Is you're going to make sure that the color reflected in the properties is the color defined by layer, okay? Once you have that, this is actually a model that's ready to go, okay? So what we would actually do is now put this model on Rhino, okay? And then we'll cut it, yeah? So this is the point where we sort of run out of things to do outside and we know to head inside. Question? I'm already in Rhino, but this one, I need the Rhino inside the computer to access the software, okay? So in a very calm and orderly fashion, could I get everyone to slowly move inside the makerspace, okay? And sort of put your bags underneath tables and let's head towards the laser cutter, okay?